When troubleshooting flickering Troffer lights, especially in a 277-volt lighting system, there are several potential causes to investigate. Firstly, consider residual voltage. When a switch is turned off, a small amount of voltage might remain in the circuit due to inductance in the ballasts. This residual voltage can cause the Troffers to flicker briefly before fully discharging. Secondly, a faulty ballast is a common culprit. A defective ballast can lead to flickering as it struggles to regulate the voltage to the lamps. Thirdly, wiring connections play a critical role. Loose or damaged wiring connections can create resistance and cause voltage fluctuations, resulting in flickering. Fourthly, assess lamp compatibility. The ballast might not be compatible with the lamps being used. This can cause flickering as the ballast attempts to adjust to the different electrical characteristics of the lamps. Fifthly, examine for induction. If there's a large motor nearby, induction can cause voltage spikes when the motor is turned off, which can cause the Troffers to flicker. To effectively troubleshoot the issue, follow these steps. Check wiring. Verify all wiring connections are tight and secure. Pay close attention to the connections at the ballast, the lamp holders, and the switch. Use a multimeter to check for voltage drops across connections, which can indicate a loose or corroded connection. Test the ballast. Replace the ballast in one of the flickering Troffers with a new one. Ensure the replacement ballast is the correct type and voltage rating for the lamps being used. If the flickering persists after replacing the ballast, it might not be a ballast issue. Check lamp compatibility. Ensure the ballasts are compatible with the lamps being used. Consult the ballast manufacturer's specifications to verify compatibility. Different types of lamps have different electrical characteristics, and using an incompatible ballast can cause flickering and reduce lamp life. Check grounding. Verify that the electrical system is properly grounded. A poor ground can lead to voltage fluctuations and flickering. Use a multimeter to check the resistance between the ground wire and a known good ground point. The resistance should be very low, ideally less than 1 ohm. Inspect for induction. Check if there are any large motors in the vicinity that could be causing induction. If so, try turning off the motor to see if the flickering stops. If the flickering stops when the motor is off, consider installing a line filter to reduce the effects of induction. Additional tips include using high-quality ballasts and lamps. Ensure the ballasts are rated for the voltage being used, which is 277 volts in this case. Using high-quality components can improve the reliability and longevity of the lighting system. If the flickering continues after troubleshooting and replacing the ballasts, consult with a qualified electrician for further diagnosis. They can use specialized equipment to identify and resolve more complex electrical issues. When dealing with electrical systems, always prioritize safety. Disconnect power to the circuit before working on any wiring or components. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electrical systems, consult with a qualified electrician. Consider the age of the installation. Older installations may have components that are nearing the end of their service life. Over time, wiring can become brittle and ballasts can degrade. Replacing aging components can improve the reliability and performance of the lighting system. Check for any signs of damage to the wiring or components, such as discoloration, cracking, or corrosion. Replace any damaged components to prevent further problems. Ensure the lighting fixtures are properly installed and supported. Loose or improperly installed fixtures can vibrate and cause wiring connections to loosen over time. Use appropriate mounting hardware and ensure the fixtures are securely attached to the ceiling or wall. Consider the ambient temperature. High ambient temperatures can affect the performance of ballasts and lamps. Ensure the lighting fixtures are adequately ventilated to prevent overheating. Consult the ballast and lamp manufacturer's specifications for recommended operating temperatures. Check for any voltage fluctuations in the electrical system. Voltage fluctuations can cause flickering and reduce lamp life. Use a voltage meter to monitor the voltage of the lighting fixtures. If the voltage fluctuates significantly, consult with an electrician to investigate the cause. Ensure the lighting fixtures are properly maintained. Regularly clean the fixtures to remove dust and debris, which can reduce light output and increase operating temperature. Replace lamps as needed to maintain optimal light levels. When replacing lamps, use the same type and wattage as the original lamps to ensure compatibility with the ballasts. Consider upgrading to energy-efficient lighting technologies. Replacing older fluorescent fixtures with LED fixtures can significantly reduce energy consumption and maintenance costs. LED fixtures also have a longer lifespan and produce less heat than fluorescent fixtures. When upgrading to LED fixtures, ensure the fixtures are compatible with the existing wiring and electrical system. Consult with an electrician to determine the best LED lighting solution for your needs. Check for any electrical code violations. Ensure the lighting system complies with all applicable electrical codes and regulations. Electrical codes are designed to ensure the safety and reliability of electrical systems. Consult with an electrician or electrical inspector to verify compliance. Consider the use of lighting control systems. Lighting control systems can be used to automatically turn lights on and off based on occupancy or time of day. This can help to reduce energy consumption and extend lamp life. When installing lighting control systems, ensure the systems are compatible with the lighting fixtures and electrical system. Consult with an electrician or lighting control specialist to determine the best lighting control solution for your needs. Check for any electromagnetic interference (EMI). EMI from other electrical equipment can cause flickering in fluorescent lights. If you suspect EMI, try moving the lighting fixtures away from the source of the interference or shielding the fixtures. You can also use a line filter to reduce the effects of EMI. Ensure the lighting fixtures are properly grounded to reduce the risk of EMI. Consider the use of surge protection devices. Surge protection devices can protect lighting fixtures from voltage spikes caused by lightning or other electrical disturbances. Voltage spikes can damage ballasts and lamps and cause flickering. Install surge protection devices at the main electrical panel and at the lighting fixtures to provide comprehensive protection. Check for any harmonic distortion in the electrical system. Harmonic distortion can cause flickering and reduce lamp life. Harmonic distortion is caused by nonlinear loads such as electronic ballasts and variable frequency drives. Use a harmonic analyzer to measure the harmonic distortion in the electrical system. If the harmonic distortion is excessive, install harmonic filters to reduce the distortion. Consult with an electrician or power quality specialist to determine the best harmonic filtering solution for your needs. Consider the use of power factor correction capacitors. Power factor correction capacitors can improve the power factor of the electrical system. A low power factor can cause voltage drops and increase energy consumption. Install power factor correction capacitors at the main electrical panel or at the lighting fixtures to improve the power factor. Consult with an electrician or power quality specialist to determine the appropriate size and location of the capacitors. Check for any neutral to ground voltage. Neutral to ground voltage can cause flickering and other electrical problems. Use a voltmeter to measure the voltage between the neutral and ground wires at the lighting fixtures. The voltage should be very low, ideally less than 2 volts. If the voltage is excessive, consult with an electrician to investigate the cause. Consider the use of shielded wiring. Shielded wiring can reduce the risk of EMI and voltage drops. Shielded wiring has a metallic shield that surrounds the conductors and protects them from external interference. Use shielded wiring in areas where EMI is a concern or where long wire runs are required. Ensure the shielded wiring is properly grounded to maximize its effectiveness. Check for any water damage. Water damage can cause corrosion and electrical problems. Inspect the lighting fixtures and wiring for any signs of water damage. If you find water damage, repair the source of the leak and replace any damaged components. Ensure the lighting fixtures are properly sealed to prevent water from entering. Consider the use of corrosion-resistant materials. In corrosive environments, use corrosion-resistant materials for lighting fixtures and wiring. Corrosion-resistant materials, such as stainless steel and aluminum, can withstand harsh conditions and prevent corrosion. Apply a corrosion-resistant coating to the wiring and connections to further protect them from corrosion. Check for any insect or rodent damage. Insects and rodents can damage wiring and cause electrical problems. Inspect the lighting fixtures and wiring for any signs of insect or rodent damage. If you find damage, repair the damage and take steps to prevent future infestations. Seal any openings in the building to prevent insects and rodents from entering. Consider the use of tamper-resistant fasteners. Tamper-resistant fasteners can prevent unauthorized access to the lighting fixtures and wiring. Tamper-resistant fasteners require special tools to remove, making it difficult for vandals or unauthorized personnel to tamper with the electrical system. Use tamper-resistant fasteners in areas where security is a concern. Check for any excessive vibration. Excessive vibration can cause wiring connections to loosen and lead to electrical problems. Inspect the lighting fixtures for any signs of vibration. If you find excessive vibration, take steps to reduce the vibration. Use vibration damping materials to isolate the lighting fixtures from the source of the vibration. Consider the use of flexible conduit. Flexible conduit can protect wiring from damage and make it easier to install. Flexible conduit is a flexible tube that can be bent and shaped to fit around obstacles. Use flexible conduit to protect wiring in areas where it is exposed to physical damage. Ensure the flexible conduit is properly supported and secured. Check for any excessive heat. Excessive heat can damage wiring and cause electrical problems. Inspect the lighting fixtures for any signs of excessive heat. If you find excessive heat, take steps to reduce the heat. Ensure the lighting fixtures are adequately ventilated and that the lamps are not exceeding their rated wattage. Consider the use of heat-resistant wiring. Check for any signs of arcing. Arcing is a dangerous electrical phenomenon that can cause fires. Inspect the lighting fixtures and wiring for any signs of arcing, such as burnt or melted insulation. If you find signs of arcing, immediately disconnect the power and consult with an electrician. Arcing can be caused by loose connections, damaged wiring, or faulty components. Ensure all electrical connections are tight and secure to prevent arcing. Use arc fault circuit interrupters of size to protect against arcing. Check for any signs of overheating. Overheating can damage wiring and cause electrical problems. Inspect the lighting fixtures and wiring for any signs of overheating, such as discolored or brittle insulation. If you find signs of overheating, take steps to reduce the heat. Ensure the lighting fixtures are adequately ventilated and that the lamps are not exceeding their rated wattage. Consider the use of temperature sensors to monitor the temperature of the wiring and component. Check for any signs of corrosion. Corrosion can damage wiring and cause electrical problems. Inspect the lighting fixtures and wiring for any signs of corrosion, such as rust or green deposits. If you find signs of corrosion, clean the corroded areas and apply a corrosion-resistant coating. Consider the use of corrosion-resistant materials in corrosive environments. Check for any signs of physical damage. Physical damage can compromise the integrity of the wiring and cause electrical problems. Inspect the lighting fixtures and wiring for any signs of physical damage, such as cuts, abrasions, or punctures. If you find signs of physical damage, repair or replace the damaged wiring or components. Protect the wiring from physical damage by using conduit or other protective measures. Check for any signs of improper installation. Improper installation can lead to electrical problems. Inspect the lighting fixtures and wiring for any signs of improper installation, such as loose connections, exposed wires, or incorrect wiring methods. If you find signs of improper installation, correct the installation to comply with electrical codes and standards. Consult with an electrician if you are unsure about the proper installation methods. Check for any signs of overloading. Overloading a circuit can cause overheating and electrical problems. Ensure that the circuit is not overloaded by checking the amperage draw of all the devices connected to the circuit. The total amperage draw should not exceed the rating of the circuit breaker. If the circuit is overloaded, reduce the number of devices connected to the circuit or install a larger circuit breaker. Consult with an electrician before installing a larger circuit breaker to ensure that the wiring is adequate to handle the increased current. Check for any signs of improper grounding. Improper grounding can lead to electrical shock hazards and equipment damage. Ensure that all electrical equipment is properly grounded according to electrical codes and standards. Use a ground tester to verify the integrity of the grounding system. If you find signs of improper grounding, correct the grounding system to comply with electrical codes and standards. Consult with an electrician if you are unsure about the proper grounding methods. Check for any signs of water intrusion. Water intrusion can cause corrosion and electrical problems. Inspect the lighting fixtures and wiring for any signs of water intrusion, such as water stains or dampness. If you find signs of water intrusion, repair the source of the leak and dry out the affected areas. Protect the electrical equipment from water intrusion by using waterproof enclosures and sealing any openings. Check for any signs of pest infestation. Pest infestation can damage wiring and electrical equipment. Inspect the lighting fixtures and wiring for any signs of pest infestation, such as droppings or nests. If you find signs of pest infestation, eliminate the pests and repair any damage. Seal any openings to prevent pests from entering the electrical equipment. Check for any signs of improper ventilation. Improper ventilation can lead to overheating and reduce lamp life. Ensure that the lighting fixtures are properly ventilated to allow heat to dissipate. Clean the ventilation openings regularly to remove any obstructions. Consider using fans to improve ventilation in enclosed spaces. Check for any signs of voltage drop. Voltage drop can cause dimming and reduced performance of electrical equipment. Measure the voltage at the lighting fixtures to determine if there is excessive voltage drop. If the voltage drop is excessive, increase the size of the wiring or reduce the length of the wire run. Consult with an electrician to determine the appropriate wire size and length for the circuit. Check for any signs of harmonic distortion. Harmonic distortion can cause overheating and reduced equipment life. Use a harmonic analyzer to measure the harmonic distortion in electrical system. If the harmonic distortion is excessive, install harmonic filters to reduce the distortion. Consult with an electrician or power quality specialist to determine the appropriate harmonic filtering solution for the electrical system. Check for any signs of neutral current. Neutral current can cause overheating and electrical problems. Measure the current in the neutral wire to determine if there is excessive neutral current. If the neutral current is excessive, investigate the cause and take corrective action. Excessive neutral current can be caused by unbalanced loads, harmonic distortion, or improper wiring. Consult with an electrician to troubleshoot and correct the neutral current problem.